We are going to heavily modify this app later in the course. To start off, let's explore the existing app as it is currently deployed in the GlobalMantix environment. I'm currently logged in to our trusty dev box in the Module 2 directory. Keep in mind, we've already explored this code in depth in previous courses, so I won't be explaining every line. We see some Docker-related files and a source code directory. Let's see what's inside. Most of these non-Python files are static HTML, CSS, and JavaScript files. These came from Initializr, a service used to bootstrap simple websites. Let's check out the index.html template file. It's a plain HTML file with a twist. I'll jump down to the action. Using a text templating language known as Jinja 2, we can easily substitute Python variables into HTML. We can also apply logic like conditionals, loops, and comments. In this case, if the account balance is defined, we print it out. If the balance is undefined, which means our database didn't have an entry for a specific account, we print a clear message saying so. This page gets rendered whenever an HTTP request is received. Next, let's check out the database class which manages our accounts. We import JSON because we'll need to load our initial data. Jumping down to the constructor, we see it takes in a file path. Next, it opens the file and stores the data in memory. The balance method takes in an account ID, then checks for a matching dictionary key in the JSON loaded data. If there's a match, it computes the balance, then returns a nicely formatted string. If the key doesn't exist, none is returned, indicating an unknown account. The last big component is the start.py file, which defines the Flask app. I'm importing some common Flask functionality, which will allow us to render HTML web pages and process HTTP requests. Here's our custom database class being imported from the database module. Next, we initialize the Flask app and database. The database has its accounts loaded in from a JSON file named initial.json in the data directory. Let's quickly open that file. This is a hierarchical dictionary structure encoded as JSON. There are 3 keys that represent unique account IDs. The value of each key is another 2-key dictionary carrying the amount paid and the amount due. Let's jump past the initial setup. This index function is called anytime an HTTP GET or POST request is sent to the website's /URL. Our simple app doesn't have any other URLs, so this function gets a lot of action. A simple if statement checks for a POST versus a GET. If it's a POST, the client has entered some data in the account ID field. This is the user asking for the balance of a specific account. Our first step is collecting the account ID field from the web form and storing it as a Python string. Then, we can use the balance method in the database class to convert it into the proper US dollars format. Last, we write a log message to assist with troubleshooting. If the app received a GET request, we set the balance to NA, which triggers the template to display an error message rather than crash the program. At the very end, we run our Flask app with debugging enabled and listening on all local IPs, making it publicly accessible. The Docker file describes how our application should be packaged into a Docker image. Let's take a quick look. At a basic level, we are starting with a Python 3.7.3 lightweight Alpine image, then installing Flask using pip. In a previous course, I used a bind mount to share the source code with the container. This time, I'm using the copy command that makes the container a bit larger but much more portable. I'm copying the entire source directory into the container so that the code comes pre-packaged. We then expose TCP port 5000 and start the program. Last, let's explore the Docker Compose file, which facilitates fast container setup and teardown. We only have one service present named CRM. This will build a new Docker image based off the local Docker file we just explored and use the name of CRM and the version tag of latest. We map container port 5000 to published port 5000 for external access. Let's quickly test it out. I'll use Docker Compose Up, which will build the image and run it locally. Let's switch to a browser to test it out. I've navigated to crm.njrusmc.net on port 5000. Let's punch in a valid account like account 100 to ensure we get a valid balance. Okay, $40 is correct. You may not remember, but this specific account has $100 due, but paid $60 so far, so the math checks out. Let's try an invalid account like Nick123 to make sure we see an error message. Okay, that account wasn't valid. Let's check our shell logs next. We can see the initial HTTP GET followed by 2 HTTP posts, one for account 100 and one for Nick123. At this point, you should be sufficiently refreshed on the basic behavior of our app.